Finally, mathematical practice number 8. Look for and express regularity in repeated reasoning. So, what does this mean? Mathematicians notice repetition. They use observations and reasoning to find shortcuts or generalizations. We don't need to teach them the shortest, most efficient way. They can figure out one, and it'll be very similar to the shortest way we do things. They evaluate the reasonableness of intermediate results, meaning, as they do step one, does this make sense? Is there a pattern that is we're following? As we're trying to add numbers, is there a pattern that things are following? So there's a story of a great mathematician whose last name was Gauss. And when he was in third grade, his teacher wanted to keep the students busy for a while so that they would have to sit in their desks and the teacher could do whatever she needed to do. So she said, I need you to add together all of the numbers 1 through 100. And when you finish, bring me the answer. Thinking, oh, this is going to take him an hour to do. In about 2 minutes, a student came up and said, I have the answer. And she was surprised because he had the correct answer. So is he really quick at adding 1 plus 2 plus 3 plus 4 plus 5? No. He figured out the pattern. So what would the pattern be? Well, if you take the first and the last number and add them together, 100 plus 1, you get 101. 99 plus 2, you get 101. 98 plus 3, you get 101. 97 plus 4, you get 101, and so on. And he realized that I have 101 numbers. How many times? Well, if I fold it on half, I have 50 times. So he just did 101 times 50, and he got 5,050. So he didn't go through the process of adding them all up. He figured out a pattern. And he knew that something was repeated. One way that we look for patterns is we use data to explain the rules. So here we have the number of cars and the number of tires. So how do I get from the number of cars to the number of tires? If I had 20 cars, could I predict how many tires there would be? This is easy for fourth graders to figure out. But do we allow them time to do it? Do we give up when they say, oh, this is too hard, I don't know, give me the answer? How do we handle that? We help them understand that they need to look for the pattern. We need to model it for them. In first grade, we have 10 plus 1 and 10 plus 2 and 10 plus 3 and 10 plus 4. Wait, now when we get the answers, 11, 12, 13, 14, 15, 16, now they understand that the 1 represents 10 and the ones digit represents how many ones. Did you ever think about the nines rule? 9 plus 1 is 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. So I want you to look at the first digit in the tens place and how it relates to the number being multiplied by 9. So in the first one, what's in the tens place? A 0. What is 9 being multiplied by? A 1. Okay. In the next one, what's in the tens place? A 1. What's 9 being multiplied by? A 2. Oh, maybe there is a pattern. Let's look. 2 is in the tens place. It's being multiplied by a 3. Oh, it's 1 less. Now, we also know that whenever you multiply something by 9, the sum of the digits is 9. 1 plus 8 is 9. 9 plus 0 is 9. 2 plus 7 is 9. So if it's 9 times 4, the first digit has to be 3. And 3 plus what is 9? 3 plus 6 is 9, so it's 36. These are patterns that students can understand. This is why if you know the fingers trick, this is why it works. Because if you multiply by 2, you go over 2, 1, 2, and the first digit is 1 less, and then you have 9 because you have 9 fingers up. That's why the fingers tricks works. Mathematicians are observant. They notice repetition and try and make sense of it. How many times in our class do we put up a bunch of multiplication problems and let the students try and figure out the pattern? Or do we just tell them? How many times in multiplication or in a math class do we just tell them what the next number will be instead of letting them predict it from things that they know? As they find a rule, then that rule will become theirs and they won't forget it. When I was teaching in 7th grade, we were talking about how to find the sum of the interior angles. I know that sounds boring, but I found a pattern. And I knew that I counted the corners and minus 2 and then multiplied by 180, and I'd get the sum of all of the interior angles. It didn't matter what the shape was. Well, I thought that I was a genius. And so I looked it up, and sure enough, that formula has been come up with before. But have I ever forgotten it? No, because I looked for patterns, I was observant, and I made sense of the patterns. Give your students opportunities to look for patterns.